Okay, before we start this lesson, we want to talk about a couple of vocabulary words that we're going to see. Arithmetic means it's the missing terms in a sequence. So if I have this, these are the arithmetic means because they are the average between the numbers there. So that's arithmetic mean. And then we're also going to see the vocabulary word sigma. And you might have seen this in standardized texting, but it looks like this. That's a sigma notation. It's a Greek letter for sigma, and it means the sum. So you're going to do this. You're going to be adding different answers together. So I just wanted to bring those up because you're going to kind of see those. Might be something new that you haven't seen for a while before. So we're first going to talk about the arithmetic sequence formula or equation, and that is this. And we kind of talked about this yesterday or in the last lesson. This is really just point slope. Remember, arithmetic is linear, so you can still write it just as you would a linear equation and not memorize this, but this is something I won't have on the test. But if you can see, our point slope equation is this: y minus the y of my point equals m times the x minus the x of my point. And we're, in this case, always going to use that first term because this is the first term. So this is the first term number, and this is the first term itself. But still just point slope. But we're going to look at this equation using this equation quite a bit today. So we're going to find the 20th term. So we go back to this equation. Want to talk about a few things I did not talk about. A1 is your first term. N is your term number. So if I'm looking for the 20th term, 50th term, that would be there. And D is your common difference, that rate. And AN is what the term is. Remember, X is your term number, Y is your term, if you're looking at it on a coordinate plane. So here I'm finding the 20th term. So I want to find A20 is what I'm looking for. So my N is 20. My A1, my first term, is 3. And my common difference is 7. So I can put that in the equation. I'm looking for A20, don't have that, the 20th term. And A1 is 3 plus N, my N is 20, that's my term number I'm looking for, times my common difference. So 3 plus 19 times 7, 3 plus 133 equals 136. So that's the 20th term in this sequence. So sometimes they'll give it to you in written form like we see here, or sometimes, like I said, it might look like this, and that also means that we're looking for the 17th term. Okay, so next we're going to look at writing an equation. And remember, last lesson we talked about this is your 2 points are, we could use any of these 2 points, like 1, -8, and write an equation, and 2, -6. And I'm alright if your equations are still just looking at that linear and writing it off at 2 points, because that's the same thing we're going to be doing. But if we use the equation, we're write an equation for any term. So A1 is -8. N, we don't know. We're just going to leave that's our variable that we're going to need to add. And our common difference is 2. It's going up by 2. So I'm going to go ahead and distribute. So I can simplify 2 times N is 2N. 2 times -1 is -2. And then place our common terms together. And there's my equation, 2N minus 10. So that's just writing that, but again, you see that just like we talked about yesterday, my common difference is my slope, so we see that here. And this is your y-intercept, like it is on a point on an equation. Your y-intercept would be what would be a zero term if there was such a thing, and that would be the term before -8, so -10. And you see that right there. So you can kind of go to that without writing out all those steps, but this is just using that arithmetic equation. Okay, sometimes they don't give us our first term, so then we're going to have to use that equation to find the first term. They gave us the sixth term, so we know when n was 6, we had 11. So I'm going to put 11 as my an, and I'm going to use this to find a1 so I can write my equation. So a1 plus n is 6 in this case. That's how they got 11, and my d is -11. So 11 equals a1 plus 5 times -11, -55. Add 55. 66 equals a1. And it kind of makes sense if you think about it. They went down by 11 5 times to get to 11. So what did I start with? So I went down by 11 5 times. So 5 times 11 is 55. So I subtracted 55 total, and I'm left with 11. So what number would that be? That would have to be 66. Right, now that we have a1, we can write our nth equation. So we have 66 plus n minus 1 times -11. Distribute. Put our common terms together. And there's my equation. Okay, so I'll let you go ahead and try those two. You have a lot of content today. So we're going to use that fact. I'm going to show you a couple ways on this one. So what we have here, first term's 21. They added something, got a term, added that same thing, got a term, added that same thing, got a term, and then added again, got 45. So we want to know what are these missing terms. So a few ways you can think about that. We added something one time to get this term, 2, 3, 4, and we ended at 45. So if I know how far I went, what's the distance or the length between those, 24, and I know I added something 4 times, even something, it's the same thing, so it has to be in even increments, and I get 6. So I know I'm going up by 6, so that's 27, 33, and 39. Okay, and we always talk about that there's always more than one way. This is kind of reasoning it out and understanding that what's going on and using that reasoning. Total great method. We can also continue with our equation. We know first term a1 is 21. We know the fifth term is 45. We know so then in this case, if we use that fifth term, our n was 5. So I'd go 45 equals first term plus 5 minus 1 times d. We don't know d. So 45 equals 21 plus 4d. Subtract 21. 24 equals 4d. d equals 6. So again, we get that difference of 6. So kind of two methods you can use, either one, to solve that. All right, we're going to go kind of quickly through this. So this leaves us to sums. So when I'm wanting to add a portion of a sequence, it's called a series. So arithmetic series would be a sum of some of the terms. So we have two equations here, and you can use either one. This one's good if you have the first and last terms. This one's good if I have the first term and d, but I don't have the last term. So d would be what I'm going up by. Okay, we do on both of these, notice, need to know what n is. So if I don't know n, the number of terms I'm adding together, I can't do either one. So what this wants is me to add all the terms in the sequence from 8 to 80, but we don't know what term number 80 is. So we're going to use our original equation. So a1 is 8, D is 4, and N we don't know. But we know that the last term, AN, is 80. We don't know the term number, so we're going to use that equation we've been looking at. 80 equals 8 plus N minus 1. We have to have N for either equation. So 80 equals 8 plus 4N minus 4. Put our common terms together. 80 equals 4N plus 4. Subtract 4 and divide. N equals, so we get 76 divided by 4, 19. So this is the 19th term. So now I can find the sum of the 19 terms that I want. So I would do first term, or N, 19, times the first term plus the last term divided in half. So 19 times 44, and I believe that's 836. All right. So these next couple examples use series. Here we're given the sum, we're going to find those terms, work with that a little bit, but I want to get to summations. So like I talked about, we're going to see this Greek word sigma, and sigma means the sum. And so you have an equation here, and we see that's linear. So since it's linear, it's also arithmetic, because it kind of goes both ways. So what this is asking me to do is find the sum of plugging in 1 for k, 2, 3, 4, all the way till I get to 12. So plug in every number from 1 to 12 in for k, and then add all of those answers together. A lot, especially if this number is like huge. So we're going to use our new series that we just learned about to find that, because so remember with that series we need A1. So plug in 3, that will give me my first term that I would have gotten in that sigma. AN, last term, is plugging in 10. And then my N, so we're going to plug in the numbers from 3 to 10. So 3, 4, 5, 6, 7, 8, 9, 10, which is 8. But because you're doing all the numbers from 3 to 10, so that's 7. Plus we want to include 3. So that's how we get 8. So then we can just do the series of 8 on this equation, and we would get 8 times 7 plus 21 over 2, sorry. So 8 times 14, which is 112. All right, if you have any questions, make sure you're coming in, giving you kind of the bare basics here, so you missed a lot more in class and all the discussion. So again, don't worry if you're struggling, just come in, and thanks for watching.